Good morning, everyone. Welcome to SciPy 2021. This is the Introduction to Python and Programming tutorial session. It's being taught by Matt Davis, who has done this for the past several years at previous SciPys. And with that, I'm going to turn things over to Matt.
Well, thank you, Eric. Let me know if you can't hear me or anything. You can use our Slack channel or the chat in here to let me know. I've never used this platform before, so we'll see how it goes. Hopefully you'll be able to hear me all right. So let me introduce myself. My name is Matt Davis. Like Eric said, I've been doing this for a few years. I think this is probably my 10th or 11th time attending a SciPy, maybe my 4th or 5th time teaching this tutorial. And let's see, my background. I live in California, in the Bay Area, near San Francisco. I kind of got into Python while I was in astronomy. I've used Python in space or in astronomy, in like earth sciences, and now I kind of work in the tech world here in the Bay Area. I work currently for a company called Populous that helps cities manage scooter, bike programs, and other issues kind of around transportation in their cities. And we use Python across the back end, and it's a great tool for us because we're a data company, but also we have a web application and a lot of like data processing pipelines that have to run in an automated way. So Python is a great tool that allows us to use the same language across all of those applications. So from the geospatial data processing that we do to the orchestration of database things to the web application backend. So big fan of Python, obviously. I've been using Python since 2008 now, and still love it. It's great. So I hope you enjoy the tutorial and kind of get a good taste for why Python is great here. And then go learn about all of the cool stuff in the ecosystem throughout the rest of the tutorial. All right. So, as you probably know already, Python is super useful in sciences, as indicated by like this conference and the size of this conference. I've used it in several fields, and as you look at the schedule, you'll be able to see just how many different applications that Python has in the sciences and even in kind of adjacent fields like engineering and manufacturing, all kinds of stuff. It's a lot of fun to come to this conference and see all those different applications. And I hope you'll be able to use it in whatever you're doing too. The scientific Python ecosystem itself is massive now. You'll probably learn here about some of the kind of foundational libraries like NumPy, SciPy, Matplotlib, Pandas, scikit-learn. But it's a huge ecosystem, and if you get out there into your search bar and search for whatever you need, like there's a good chance that there's something out there. So do your research and look around for it. About this tutorial, you'll notice me looking off this direction. I have another monitor where I have some other stuff up. We have a Slack channel that we probably won't use too much, but I'll have it up. You can use it to ask questions or talk to the other members of the tutorial. You can also use the chat here. I see it going by. Both of those work. Like I said, I haven't used this platform before, but we'll try to use the different feature. I'll try to keep an eye on the different features of it. There's like a raised hand thing that you can do, a Q&A for asking questions. So any of those is fine. However you want to do it, and we'll try to make it work. So this tutorial is the introduction to Python and programming. I kind of run this for people who kind of want to get into the Python ecosystem, but maybe don't have a lot of programming experience. Maybe you use Excel or SQL or something, but don't do a lot of programming, or maybe you program in some other language, or have dabbled in Python and want to dive in deeper. The time we have today isn't enough to really get deep on Python, but I'm hoping to teach you enough that you can get into the other tutorials you've signed up for and focus on the content of those and those libraries, and not be worried about Python syntax, not worried about how to use variables, how to use lists or indexing. We want to cover that here. But there is a whole lot we're not going to cover. So I hope you get to kind of continue your journey after this, getting deeper into Python itself, in addition to the libraries you're going to learn about in other tutorials. Good resources for that are the online documentation for Python, which is pretty good. There are a lot of books. I personally in the past have used the O'Reilly books, Learning Python and Fluent Python. Those are pretty good. Fluent Python is a more advanced book, but is very good at covering some more advanced topics in Python. Other resources, one I always plug is called Software Carpentry. Software Carpentry and some of its sister organizations, like Data Carpentry, are under a broader umbrella called the Carpentries. But they teach scientific scientists programming techniques, but sometimes Python, sometimes R. It depends on the audience. But in addition to that, they teach things like how to use the shell, how to use version control, and just different things that you'll end up finding useful beyond just programming. So definitely recommend their resources. I can post that in Slack later, a link to those. Yeah. And if you have specific questions about anything, feel free to post them here or in Slack. This Slack channel, will be here for the rest of the conference. So even beyond just the next few hours, feel free to post questions in there, or come discuss things with people. Let's see. The other big thing I want I want you to get out of this tutorial is a little bit of using the Jupyter Notebook. I think probably just about every tutorial you'll be using it, and it's a great environment for learning Python and for doing work in Python, especially with data and scientific data analysis type of stuff. You can use it in a couple of different environments, kind of the plain Jupyter Notebook. There's a new thing called Jupyter Lab that incorporates the notebook and a kind of richer development environment with terminals and text editors and things. It's sort of, for the purposes of this tutorial, it doesn't matter which one of those ways you're starting a notebook. They'll all work for our purposes. The way I'm going to do it, and kind of how we're going to get started with the setup here, is to, well, the first thing we need to do to get going with the tutorial is to open a Jupyter Notebook in the repo, in the directory that contains the tutorial content. Let me share a link to that in the chat here, so you can download the content if you haven't already. And so this is a GitHub repo. When I say repo, that's short for repository. And GitHub is a service now owned by Microsoft, but originally just a startup that is used with the Git version control tool. If you haven't used version control before, it is really important to getting work done when you start getting into code. What it does is it keeps track of changes to things over time and allows you to undo or rewind changes that you've made, or to create separate versions of your code and switch back and forth between them. Great tool. What I want you to do is actually download this code. So I'm going to share my screen so I can show this to you now. All right, so hopefully you are seeing my browser here with the air meets. I'm going to switch over to the GitHub at the link I just shared. You can download this as a zip file here, and I'll copy this link and paste it into AirMeet too. But you can download a zip file that contains everything in here and unzip that, and you'll be set with everything you need. I'm so used to like being in Zoom and being able to see and hear people. It's really unnerving to kind of just be talking to my computer and have no idea who's on the other side. That was random, but it's strange. Okay, so what we want to do is download this and unzip it. And then the next step we're going to do is to open a Jupyter Notebook running in that directory. I see your question, Kyra. No, you don't have to save it to the Anaconda directory. You can save it to your somewhere convenient, your desktop, your home folder, something like that. Jorge complimented the sunsets back here. Thank you, Jorge. These are pictures of a place in Eastern California called Mono Lake. Not taken by me, taken by a professional photographer, but very beautiful place. And somebody asked about the books. O'Reilly is the publisher of the two I mentioned, but there are a lot of Python books out there, just a lot. So it's hard to recommend just one. There are even the two I mentioned, which I'll type in here, Learning Python and Fluent Python are from the publisher O'Reilly. They also have some books that are more specific to data, quite a lot of them, in fact. There's like Python for Data Analysis by Wes McKinney. I don't know how current that one is. That's an older book. There's one by Jake Vanderplas. There's one by Katie Huff and Anthony Skopatz. I can look up all these later and maybe post them in Slack or here. But the Python is there are just so many of these resources now. It's hard to recommend one. Paul, yes, it is assumed that you have Anaconda installed. That was part of the setup instructions. To introduce, so the tutorial setup instructions said to install Anaconda. Anaconda is a package of Python and a whole bunch of the libraries from the scientific Python ecosystem, like hundreds of them, all in one big installer. And so it's a good way to get started. It might not have everything you need like for all of time, but it definitely has everything you need to get started at something like SciPy. There's a link here in the setup instructions to download it if you haven't done that already. And as you install and set up Anaconda, it'll hopefully set up everything you need so that you can have it on your system path in order to start it. But this varies by system. I'm on a Mac, so I'll be kind of demonstrating things. We'll once we all get to the notebook, it'll look the same for all of us, but kind of the process of starting the notebook varies depending on your system. So I'm going to use the terminal here on my Mac to start a notebook. On Windows, there's a different process. I think there are links for it. These instructions have kind of different instructions for testing it on different systems. So they have like Windows, Mac, Linux for starting this. Instead of typing, so these are kind of just a very quick test. This is, for Jupyter Notebook here. So we're starting Jupyter Notebook. One thing, though, is that's not in these instructions is getting to the directory you just downloaded for this repo. So we want to make sure you're in this repo before, in this directory when you start the Jupyter Notebook. But this is going to vary a little bit depending on how you're starting it. And unfortunately, I can only demo how I'm going to do it here on my Mac. Let's see. I do want to call out this option for binder. If it is just too trying to get the notebook started in the right place, and I totally understand that. There's a tool called Binder that will start a notebook for you online. And you'll see this view, and this is very similar to what you would see if you were able to start the notebook locally. And so if you, here we go. So this is Jupyter running online, and you can click on any of these things to look at it. So this is another option for doing this tutorial. Everything you need is here. The downside of this is you don't get to keep it afterwards. Binder will throw away everything you've done if your session is inactive for too long. And I don't remember what the timeout is, but it's not long. It's like 10, 15 minutes. So if that happens, you kind of have to restart it all over again, which is not a lot of fun. because you'll lose all your progress. So definitely recommend, if you're using Binder, like making sure you kind of poke it every few minutes to keep it active, your session active. Okay, I'm gonna come back here, check for any questions. Yeah. Let me get to these questions. I'll try not to go too fast here, Carmen. Vaughn, there's this link. So if you get to the repo, this link is what all I clicked on to get to Binder. Under backup option, Binder. And I can copy this into chat. But yeah, Binder is the backup option because you don't get to save your work, essentially. So if you can get Jupyter going locally, definitely recommend that. So let me demo how I do that. So I'm going to switch to my terminal. I can embiggen a little bit, but I'm not going to use this much, so it doesn't matter too much. So again, I'm on a Mac, so I'm here at my command prompt in the terminal application. And I am in the directory corresponding to the repo. So if I show the files here, it will mostly match the files from the repository. And to start a notebook here, I am going to, does this work? Do this, Jupyter Notebook. So that's Jupyter-Notebook. And press return. And it's going to open a new browser tab with, again, listing the contents of the directory here. So this is where we want to get to. So if you are seeing something like this, perfect. You are all caught up. So what I typed there was Jupyter Notebook. Start the notebook. But it was important that I was doing that there in that particular directory. Yeah, Aaron, I launched the notebook from the terminal, which on a Mac or on a Linux computer is kind of the only way. On Windows, there are some other options, but using their instructions, I think the way I do it, I'm going to open this again. Oh, wait, not that. These instructions. Okay. So good news is this is probably going to be the most difficult part of the tutorial. Once we get everybody set up and able to run Anaconda, it's smooth sailing from there. So Aaron, what kind of computer are you using? You're on a Mac? Okay. That's probably a sign that your path doesn't have the Anaconda installation on it. Did you So you downloaded Anaconda. Did you also like run the Anaconda installer? Okay. Let's see, where does Anaconda, I think it usually installs to your home directory. So if you do, let's see, this isn't going to work for me, but do something like this. I think that's where Anaconda installs. Could be wrong about that. So Aaron, if you run that and show me the output, that will be helpful. Interesting. Let's see. Okay. Yeah, Aaron, you can always use the binder if you have to, but hopefully you can find out where Anaconda is installed and find Jupyter and start it. Okay, how's everybody doing? Maybe I can use a poll for this. I see a lot of thumbs up on the screen, so that's promising. In general, there's a there's a lot of terminology I'm probably going to use without even realizing it that I'm using jargon. Feel free to throw a question out there if I say a word that you don't know, and I will explain it. A big part of learning this stuff is learning the vocabulary and the jargon. So I'll do my best to call out when I'm doing that. But if I breeze past something without explaining it, feel free to call it out. And we won't be using Spider as for this tutorial. On Windows, how I would do this when I've done this before is to use these. You kind of do this. Find this Anaconda. It comes with something called the Anaconda Prompt, which opens a Windows terminal that is set up in such a way that you have access to the Anaconda installed Python and other tools like Jupyter. So when you start this Anaconda prompt, it opens up a terminal that'll look kind of like my terminal, where you're going to issue text-based commands. From there, I can't remember what the tricky part there is getting to the directory where you unzipped the code you downloaded from my repo. So you have to navigate to that. I think you can do it either by navigating here at the terminal, and I think you have to use commands like the dir command to change directories, or wherever it starts, you can open Jupyter and try to navigate around, but I'm not sure how well that works. I'm looking here, and this doesn't give me access to like move around the file system, I don't think, or at least to move like to higher directories and see other parts of my computer, only the stuff in this directory. Joanna, that's probably fine. Oh, nice, Aaron. Glad you got it running. Oh, using a notebook within VS Code. Yeah, that's great. That will probably work as well. Sandra, it's fine. Whatever. The only requirement is that you can run a Jupyter notebook. So as long as you've got that, you're set. And I'm just going to give everyone a few minutes to fiddle with that. But let me pop back over here. When you've got Jupyter running and you're in the directory from the repository, it'll look like this. While everyone's getting there, I'll just kind of talk a little bit about the rest of the tutorial. We're going to just be doing a bunch of exercises. Kind of the structure of it is I will demo something for you, and then turn it over to you to do an exercise, trying out what I just showed, and then we'll come back after a few minutes and I'll kind of show how I would do it, and we'll keep moving through that. We'll see how far we get. I've never gotten through all of the content I have here, and that's fine. We just get as far as we can. If you find that I am going too slow for you, feel free to work ahead. There's no reason you can't do that. We will be starting off first in this playing with blocks. The blocks part will become apparent in a little bit. Playing with blocks notebook. It'll also be useful to have this playing with blocks file open. You can open it here. You can open it in the repo. So if I click on that here, it opens this up in a text editor. Which is fine, but it's rendered as text, as just kind of raw text. If I open up this same file on the GitHub repository, this is playing with blocks exercises, and I'll paste this into AirMeet. This is rendered a little nicer. Carmen, yeah, if you're seeing something like this where it says Jupyter at the top and it has this listing of the files, like that's exactly where you should be. Aaron, you don't. We're going to be working entirely in the notebook for this tutorial. In some of the other tutorials you may use a text editor. You can use whichever one you like. For this tutorial, strictly the Jupyter notebook. Yeah, if you haven't done a lot of programming, you might not be familiar with text editors, plain text editors that people use for code. VS Code is one, a popular one from Microsoft. It's the one I use for my work. Atom is another one, originally made by GitHub. And there are many. I've seen PyCharm mentioned in here already. That's another one. There's a lot of them. But when you're writing code, you want to make sure you're doing it in something that is going to save a plain text file, because that's what most tools can run. So if you're running a Python script, it needs to be a plain text file. So you're not using something like Microsoft Word or Google Docs to do that, because they don't save plain text, and they can have weird formatting and things. So as you write more code, you are going to end up finding a text editor you like and learning to love it. Varun, we're using Jupyter Notebooks because the tooling I wrote for teaching runs in the Jupyter Notebook, and because I want to get you used to using the Jupyter Notebooks, since it's such a common tool used in the tutorials and in the scientific Python world. That said, there are many different ways of running Jupyter Notebooks. The way I'm doing it, where we're kind of doing Jupyter, starting a notebook server on your computer itself, or there's Jupyter Lab, which I mentioned earlier. There are several tools that have embedded Jupyter Notebooks. I wouldn't be surprised if Spider has one, but I've never used it. VS Code has this capability. PyCharm might. It's such a common tool that it's integrated in a lot of different places. But I wrote a specific teaching tool that you're going to use that is meant to run in the Jupyter Notebook. Let's see, Paul. Let's see. Oh, I see that just turned it into a link. So Paul, you clicked on this and it came up with a blank page? Not this. Interesting. I don't know why that would be. Let's move to the next step and we'll see how that goes, since you can reference the exercises here on GitHub. So the next step of this is to see if we can actually start a Python-backed Jupyter Notebook. And we do that by clicking on, in this view, clicking on this Playing with Blocks file. Jupyter is this tool that kind of runs here in your browser, or if you're using Jupyter Lab, that runs there, the Jupyter Notebook. But it's not what executes your code. What executes your code is in the Jupyter terminology a kernel for for Ipython, for us, we're learning Python, so we're using the Ipython kernel for Jupyter, and there's some communication going on between like your browser and a web server running on your computer that then has a Python process that executes your code. And I don't want you to think about that too much, but there's kind of a, it's running regular Python. But when you go online to read about Jupyter, Jupyter is not necessarily a Python-specific tool. People use Jupyter with other backends as well, notably R or Julia, a lot of different languages. And so you need to be aware of that we're kind of using a Python-specific version of Jupyter. And if you see references to something called Ipython, that was kind of a precursor to Jupyter, but it's a thing that comes with Anaconda. It's a way you can run Python in your terminal, and anything you can run in Ipython, if you find references to it, you can run here in the notebook because we're using an Ipython supported notebook. So this is the next thing we want to get to, is this view where you see playing with blocks and these little code blocks. So, and again, I clicked on this playing with blocks.ipynb file, the .ipynb being for Ipython notebook. Because originally this was called the Ipython notebook, not Jupyter. That came later when people started using it for things other than Python. Okay. Paul, I'm not sure what can be going on there. It sounds like maybe the Jupyter server doesn't have permission to read those files, which is very strange. If you started Jupyter from the terminal, go back to mine, you'll notice that there's output here. So sometimes you may see errors printed here. And if you do, you can see that that can be helpful for diagnosing problems. Okay, so that's interesting, Paul. You'll be okay as long for the purposes of this tutorial, as long as long as you can open and run the notebook files, you'll be fine, because you can look at the markdown files on GitHub. So hopefully that'll work. The message about it being not trusted, I think, is okay. There's a view. Is there a way in here to trust a notebook? Yeah. Once you open the notebook, there's I think you can go to this file menu and maybe tell it you trust it, but I don't think it'll affect us running anything we're trying to run today. Aaron, yep. I think that's right. So if you see this, you are all caught up and ready to go. Thanks, Eric. Yeah, so Eric's saying you can interact with this. If it says not trusted, you can interact with this and be able to tell it that you trust it. So I'm going to give a couple minutes for folks to try to get to the point where they are looking at this notebook and ask any questions that come up. Maybe I should move my AirMeet window over to my other terminal so that I can have, so that you can see the notebook, but I can see your questions here at the same time. We'll see if this works. Okay. Do y'all still see my notebook? Okay. Awesome. Thank you. This way I can see your notebook, my notebook, and your questions at the same time. Exciting. Okay. So we're going to take a break in a couple minutes. So that we come back fresh to get started actually writing some Python. And everybody can kind of try to get to this point where they're in a notebook. But let me talk a little bit about Ipython Blocks. Ipython Blocks is a tool that I wrote at the suggestion of somebody named Greg Wilson, who is the founder of the software Carpentry that I mentioned earlier, as a tool for teaching Python, specifically in the notebook. And you'll see what it does. It kind of gives us a visual for our work, so that it's really easy to tell whether what we wanted to happen actually happened. We'll be playing with this like kind of low resolution pixel grid of colors where we can do things like try to change a specific pixel of that grid a color and then see if it happened. If you want to look at what Ipython Blocks is under the hood, the file is in the repo, this ipythonblocks.py file, so it's packaged up in here. And read it if you want to. There's also a website that associated with it that I hope is still running. I haven't been here in a while, we'll see. Yeah, it works. Cool. So you can, the fun thing about this is that you can publish stuff that you make in your local notebook to here and then share it. That's described here. We can go look at one. So it will, so this is the grid. This is one of the ones I made. And you can include the code for it right here in the post as well. You can also pull these down and run them. Let me see if I can find the docs for that. So all the code for generating this is right here. And oh yeah, you can see here that I used as a starting point a different grid that's published to here. Aaron, are you asking how I made this or how I made ipythonblocks.org? Still not sure exactly what you're asking. To generate this? Okay. So this is actually a website. This is not related to the notebook. But the code I ran, you can see here. So like this is the code that generates that spiral. The background of it is actually in this other one. Oh, I see. Looks like I didn't include everything in here. Oh yeah, this is everything to generate this. Yeah, so this is Ipythonblocks.org. It's a totally different website. But anyway, this tool, you can interact with this website. But this is the kind of thing we'll be looking at today. The ones I'm going to have you make are not quite this large. But it's a fun thing to play with, and you can if you end up making something pretty cool today, feel free to post it and share it with everybody. On the home page, or maybe on the about, there's instructions about how to do it. I mentioned earlier we're mostly going to be in this playing with blocks notebook. I doubt we'll get out of it, but there's actually a whole other section of this. You could, if you're like really feeling like I'm going too slow and you want to go ahead, like do all of the exercises in the playing with blocks exercises file, then open up building blocks and look at the building blocks exercise and keep going. It's the kind of more advanced part. Hopefully it still works. I've never in this tutorial actually gotten that far, so I'm not sure how up to date the instructions are in there. All right. So again, this is where if you're here, you're caught up and good to go. So I think with that, it's probably a good time to like take 5 minutes for a quick break, catch our breath, and so let's come back together in. Let's go ahead and go to like the top of the hour. I'll come back in just a minute though and be here to answer any questions or anything. But I will get started here at with the actual instruction here at 10 o'clock Central Time at the top of the hour in 7 minutes. And I will be right back. All right, I am, well, we'll still got a few minutes till I get started, but I am here if you've got any questions or anything. So Magdalena, the notebook has multiple kinds of cells, and you can change what type a cell is. Each of these is a different cell. And if you see when I go through these, this is if you look here, these are code cells. This is a markdown cell. Markdown is it's called a markup language, where you can write text in a certain format and then render it as like write text in a certain format in plain text and then render it as richer text. So if I select one of these cells and change it to markdown, it changes a little bit. And then if I type in here and do things like make a list, it'll get rendered as a list. And in fact, if I double click on this, you'll see the actual markdown here for this. And then when I run this cell by pressing Shift Enter, it renders it to HTML and displays it. All right, so we are at the top of the hour. So let's get started. So first, let me introduce the notebook a little bit and explain some of the terminology in here. You probably overheard me a little bit saying that these are cells. So each of these individual things is a cell. You'll see the currently selected cell over here with this box around it. I'm pressing the arrow keys on my keyboard to move the selection up and down. A big thing I want to call out is this help menu, which you can see here, like notebook help, markdown help. This keyboard shortcuts is pretty useful. So it's detected I'm on a Mac, showing me a certain thing. I'll say more about these two different modes in a little bit, but there's like a zillion shortcuts in here. And you will probably see me doing some stuff where something happens really fast and you're like, what just happened? I was probably using a keyboard shortcut. I'll try to call those out, but you can read all about them in here. But you don't have to use them. That's just something you'll want to learn as you get more, you spend more time in the notebook. All of these menus and these icons do a lot of the things, like cutting a cell, adding a new cell, and moving cells and so on. I was just explaining that there are different types of cells. So you can write text in here in a markup language called Markdown and do things like have links and embed images and videos, and also have code. So this is a code cell. You'll notice when I clicked into here, it inserted the cursor, and this changed from blue to green. So when this is blue, I'm in what's called command mode, which means I can do things to the notebook as a whole, like rearrange the cells and add new cells or do different things like that. When I click into a cell, or when I press return while I have a cell selected, I turn into edit mode, which means I can now edit the text inside that cell. The first pre-populated cell here is an import. So Python has a bunch of stuff that's available. I'll come back to your question, Carmen. A few things that are available without importing things, but a lot of stuff is you access by importing it. There's stuff in what's called the standard library that you can import. When you use third-party libraries like NumPy or Pandas, you have to import that. Or in this case, Ipythonblocks, we import that. When you import something, it can come from different places. So again, like the standard library, a third-party thing. In this case, it's going to import it from that file called Ipythonblocks.py that's right here in this directory. So that's where, so you could open up that file, go read the definition of this stuff that we're importing here. Carmen asked about switching between modes. Very good question. So right now I'm in edit mode, and you can see my cursor blinking in there. If I press escape, I'll go back to command mode. If I press return or enter, I'll go back into edit mode. Mouse events will also switch between modes. So right now I'm in edit mode on this first cell. If I click out here on the second cell, I'll go back to command mode. If I click inside the cell, I go into edit mode in that cell. Same with this blank cell. These cells support multi-line code. So when you press enter in here, it doesn't execute the cell, the code in the cell. It just makes a new line like this. To execute a cell, you press shift and enter at the same time. So I'm going to do that. I've got that first cell selected. It doesn't matter whether you're in edit or command mode. You shift, enter, and there it goes. So when that number appeared next to it, that means it ran successfully. There's no output printed here. This is the only indication here. Aaron, no, you do not need to be logged into GitHub for anything we're going to do. Okay, so we've imported it. Let's take a look at some of these things. One of the cool things about working in Jupyter is the help features and the completion features. So I want to show off a couple of things that we just imported. One is this colors variable. And I especially want to show off what happens when you do colors dot and then press tab twice. Oh wait, no. Yeah, there we go. Actually, maybe I didn't have to do that twice. Maybe once would have done it. Let's try. I can't remember. Okay, no, just once. So I pressed tab. I did that dot and then tab. And this little thing showed up. And what this is doing is it's showing me all of the optional completions. These are what are called attributes on the colors variable. And you can see that these are all the names of colors. These are the standard like HTML colors, which are a thing, if you didn't know that. I can pick one of these. I can click on it with my mouse. I can start typing out the name. And let's see, so if I do deep sky blue, great. And if I want to execute that, again, shift enter, and it now I see some output this time. What's going on here is that Jupyter will kind of echo or display the last thing in a cell. In this case, deep sky blue is something called a color, and it has these components, red, green, blue. For computers, a very common way of representing colors is as a mixture of red, green, and blue, where each of those is an integer between 0 and 255. So that's what this is. But we'll see more of this in a minute. Let me catch up with the questions here. For Paul, no, it's not browser dependent, as far as I know. That in star means that your cell is not running. The star shows up when, the star shows up when Jupyter is trying to run the cell, and then it changes to a number when it's done. So that means it's not finishing running. And I wonder if you're running into permission problems. Again, if you look at the terminal, it might show you something. There's possible there can be some browser issues. I would expect this to work in Chrome or Firefox or Safari on a Mac. I don't know how well Jupyter works in something like Microsoft Edge. Okay, Paul, it might work. It may not. I have no idea. Okay, Eric's saying it does. Okay. I have no experience with that. But maybe that's not your problem. But it may be another permission issue where like it's not allowing you to run code or something. Does the terminal have anything interesting to say? Okay, Internet Explorer, I definitely did not expect to work. I'm trying to think of the right way, or a way to get it to work in a different browser. You may be able to open a different browser and just copy this and paste it in. Or what it does for me is it opens in the when I run Jupyter Notebook at the terminal, it opens in whatever my most recently active browser window was. Okay, so sorry, I should have clarified this before. I'm using Chrome. Firefox should work fine. Eric says Microsoft Edge should work fine. I do not expect Internet Explorer to work. Great, Paul. Awesome. Okay, Aaron. So the steps I took. Oh, you got it. So remind us. So like the steps I took to get to where I am now were starting Jupyter. I'll refresh for everybody, Aaron. Was starting Jupyter at the command line while I was in the directory from the repository, which started a notebook server with this view that you see right now. And then I opened up this playing with blocks.ipynb file just by clicking on it, which opened up this terminal, or this window. And now we're executing code here in this window. Yeah, one thing to watch out for is that if you click on one of these in GitHub, it will actually render it, and so it'll look kind of like my the notebook screen, but it's not. So you'll see the GitHub view up here if you're there. Okay, so we okay, interesting, Paul. We'll see a little bit more of this. So let's see if other features work or not. But the tab completion is very nice, but not strictly necessary. Okay, so we looked at this. There's a lot of colors in here. You can pick which ones you like. It's just a shortcut. A lot of things in Ipython blocks work with these sets of red, green, and blue values. And the values in the colors are a shortcut for those. The actual colors we use are not important. I just want you to have fun with them. But there's a utility here called show color that sounds interesting if we want to actually see what color it is. So let's try this out. Show color. And I might, interacting with something like this, I have the question, like, what are the arguments to this? How do I tell it what color to show? It would be nice to have some information. And if the author of this code has provided documentation in the code, Jupyter can show it to us. So what I'm going to press here is another keyboard thing. I'm going to press Shift Tab. Okay. So, and this opened up this little window with the documentation. So the way you call this is to provide separate red, green, and blue values. So I'm just going to make some up. And again, Shift Enter to run this. Okay, nice deep blue color. But what if I want to show one of the colors from the colors variable, like that deep sky blue? I'm gonna try this. This time I typed out like up to here and then pressed Tab, and Jupyter finished it for me because there was only one option that matched that prefix. I'm gonna run this. I get an error saying show color is missing 2 required positional arguments for green and blue. So remember that show color is expecting 3 separate values, one for the red, green, and blue components of the color. But I also imported there's another one of these, show color triple. So let's take a look at that. I'm going to try to hide a little bit of stuff here so that you can see more of my code all at once. So let's do the same thing with show color triple. Tab completion work there. The shift tab doesn't work until you open the parentheses. So I open the parentheses to call this function, press shift tab, and here I get it. So this only takes one argument called an RGB triple. So that sounds more promising for this. Shift enter to run it, and it shows up. Let's see, a question. If you want to add documentation to a code in Python, it's the hash sign. In the notebook, too, you can always add a text cell too. So I just entered command mode by pressing escape. I'm going to press the A key. It enters a cell above here. And then I'm going to press M, which converts it to markdown. And now I can write text. That's another way to do documentation in the notebook. Pick whichever way you like. Aaron has a question. Yeah, so shift tab shows you a documentation for things like functions and classes. It doesn't. There's usually not documentation on individual variables. Yeah, so it's when you've got those open parentheses because you're going to call a function that you can use shift tab to get that documentation. There's another way to get documentation too. So now that we know how to see colors and work with them a little bit, let's take a look at the actual grid. So I want to make a block grid. I could do shift tab here. Another way to do this is with a question mark at the end. This is specific to Jupyter. If you were to do this in a Python file, it would crash when you tried to run it. But here in Jupyter, we can do this, and it opens up a wholly separate window with the documentation. You can see here on the first line, it's describing the signature for calling it. So when you're making a grid, you have to give it a width and a height. And then the rest of these have default values associated with them. So we don't necessarily need to provide these values. Fill is like the initial color. All zeros is black. If they were all 255, that would be white. You can control the size of the individual little blocks. You can change whether you want to have lines displayed as kind of the grid space between the blocks. And that's all described here. So in the parameters section, there's this attribute section, which shows information that you can access once you've created one of these grids. And then we can use Ipython's help features once we have a grid to kind of explore other stuff that's available on it. So we'll see that. When you can resize this if you want, but when you're done with it, or you can even open it in a new window. But when you're done with it, you can press this X to close that separate page. So let's make one of these. Actually call it. And see what happens. So it made a grid and displayed it there. with all of the other values with their defaults. So it's black, the lines are shown, and that's the default block size. So that's fine. But what we really want to do is create a grid and maintain a reference to it so that we can do things to it and work with it afterwards. So we're going to create a variable that points to this grid. So I'm going to do that. Grid equals block grid, and we'll do the same thing. Now when I run that, it doesn't print it. But I do have a variable now called grid. And if I put this in a cell by itself and run that cell, it will print it. Because again, this is Jupyter. If you only have one line or you have multiple lines, it doesn't matter. If the last line of the cell is like a displayable value, Jupyter will echo that back to you and show it to you, no matter what it is. So that's why we saw the grid here. That's why we saw this here. And you can see that because it has this little out signifier saying next to it saying this was the output of running cell 2. So that's one way to take a look at your grid. Another way is to explicitly do that. So I'm going to do the tab completion here thing. Grid dot, then tab. There's a lot of stuff here. I'm not going to explain them all right now, but you can do show, call that. So it doesn't take any arguments. I don't think. Shift tab. Yeah, no arguments. But if I run this, so to call something with no arguments, to call a function or a method is a function attached to a variable that takes no arguments. You just do the empty parentheses, and that'll show up too. So this is a way to make the grid show even when you're not listing it as the last element in a cell. Okay, so we are now ready for you to do an exercise. So if you have the exercises up, it's just you've probably already done it already, to make sure you have your own grid, your own 5x5 grid assigned to a variable called grid. So since you've probably been following along with me, I'm just going to give just a minute to make sure everybody's at this point and see if there are any questions. Cool. Seems like everybody's here. Kara, do you want an example of like this kind of documentation with a comment, or something more like what we saw when we do Shift Tab here? The code comments with the hash symbol, you can mix in anywhere. So we can do something like run that. And then whoops. You can mix and match code and comments like this. Not sure if that's what you're asking, but anything that begins with this hash symbol will be ignored. And you can put these here. You can put them on their own lines. You can put them at the end of the line. What error did you get? Okay. Maybe paste in the code you ran. So invalid syntax means something's not quite right with the format of the code. Could be a missing comma, a space where there shouldn't be one, missing parentheses. Okay. I think now, Kyra, go ahead and if you copy and paste it in. Oh, I see. Maybe so so you're doing block grid with the question mark. Since that's a special like Ipython syntax, it may not like it when you mix the comment with that. That's like kind of not plain Python. It's a special Jupyter command, so I'm not sure how well it interacts with the comment syntax. Yeah, I get that too. Let's try if we put the comment on its own line. Oops. That's not what I meant. Okay, so if I put the comment on its own line above it, it worked, but it didn't like it when I put it after. So I think that's because this is a special Jupyter syntax that it was somehow having trouble. It was maybe executing it as, trying to execute it as Python and not detecting that this was the last character. And this is not valid Python. Jupyter would intercept this and do something special with it before Python tried to run it. Okay, so now we're ready to do something with this grid. And what we're going to do is start editing it. We'll see a few different ways of doing this. To kind of continue the example of working with individual variables, we'll start by creating a variable referencing an individual block. So new block equals grid. And here I'm going to use square brackets instead of the parentheses I was using before. And list out a reference to an individual grid. What, Paul, I'll come back to that. It's kind of subtle, but in Python, the parentheses are usually for doing like calling a function and saying like and maybe passing in parameters like we do here. So here we're calling the code inside a block grid and saying like these are the parameters of the call, or maybe it doesn't take parameters and we're saying do whatever you do and it doesn't take parameters. But when you have a container and you want to pull something out of it, we do something that usually involves these square brackets. So if you think of the grid as a container of blocks and we want to pull something out, we use the square brackets and specify an index or multiple indexes here in this case because it's a two-dimensional structure. Python has some built-in types that do this too. The big ones you'll work with are lists and dictionaries. A list is kind of like an array, a one-dimensional array. A dictionary is a key value mapping. So with a list, you pull things out by their position in the list. With a dictionary, you pull things out by referencing their name, their label in the dictionary. With the block grid, we use positional indexing, but it's a two-dimensional structure, so we need two positions. The first one, you'll notice I'm using zeros. Python uses zero-based indexing. So the first thing in a sequence is usually index 0. And then the last one is, if you're, we'll see a trick for this later, but the last one is at position, in this case, it would be 4, because there's 0, 1, 2, 3, 4, to specify 5 things. And then the order of these is the row and then the column. So the first value is picking out which row of this, and the second one is picking out which column. So let's do something with this block we're grabbing out of here. I want to change its color. And I can do that by using my colors. So pink this time. And then back to your question, Paul. When we want to see the grid, there's a couple ways of doing that. One is to to kind of specify the grid by itself on the last line of a cell. Or you can use grid.show. When you're not using grid.show, it will only show up echoed back to you if it's the last thing in the cell and it's all by itself. You're not doing anything with it. That's kind of a special Jupyter behavior where it's interpreting the last value, the value of the last expression in a cell and saying like, okay, this looks like a displayable value. I'm going to show it to the user. Grid.show will display the grid in the notebook no matter where in the cell you call it. So that's the difference between those. So if I run this, we'll see that top left value has changed to a lovely pink color. So that an important thing to call out too is that this is indexing from the top. So 0, 0 is up here. Oh, look at that. When I hover over it, it tells me the index and what color it is. And if I go over here, so that's first index 0 for the row, 2 for the column, 0, 1, 2. Here, this is 2, 2 in the middle, 4, 4 at the lower right. Erin is asking about spaces here, whether, because she noticed that it was not necessary to put these spaces here. This space, also optional. In Python, unlike a lot of languages, there are times when spaces are required and times when they're not. You'll see that in a little bit. I'm writing it in this particular way with those spaces around the equal sign to make it more readable. Python is actually the program that runs your code doesn't care about the spaces. But as a community, Python has adopted some standards for writing code and how you format code. You can look up a document called PEP8, PEP8, that describes like the Python community's default standards for how you format Python code. But we'll see in a little bit an instance where it's actually important. The spaces are actually required and important. All right. So you are now ready to do exercises 2 and 3 from here. So I'm going to give you a couple of minutes to do that. Yeah, so Luke is asking about kind of discovering what's available on a block. And so as we've seen, there's a couple of ways to do this. We can do block dot and tab and then see all of these different things. But this doesn't tell us what they do. You can use the help feature again to pull that up and get the documentation for block. So I did block question mark. And now it's telling me about this individual block. So there's some parameters to create one. We never actually create them directly. Here are the attributes. You can see an explanation for what these different things do. Some of these are editable, some of them are not. The red, green, and blue and the RGB are. And I think size. Actually, all of these are editable, but only some of them you should edit, like the color values. Hopefully that answers your question there, Luke. Yeah, that's and that syntax for assigning it is another way to do it. Since I'm showing the variables here, I wanted to keep doing this, but we're going to switch to using the way you showed there for the rest of it, since we don't have to do so much typing. Yeah, Paul noticed that when we pulled out this block and modified it, it changed the grid itself. So this block variable is not a copy of this value. It's the same. It's holding a reference to the same block contained by the grid. So when I pull it out using this indexing and change it, it changes its state within the grid too. So it's a reference, not a copy. That's pretty typical in Python, though it's not always the case. You kind of have to discover on a case-by-case basis that when you do this, whether you're getting a reference or a copy, or you're working with something that's immutable and you can't change it anyway. With blocks, I don't think I've made a way to copy these. But the library designer could write a way to copy them. And that's going to depend on kind of exactly what the library you're working with, how to do that. Sean, it does autosave, but you can also, I recommend also saving it. Oh yeah, save and checkpoint. So I frequently, on my Mac, I'm pressing Command S, like the usual save key stroke. You can also do it from the file menu, or if you still have the header visible, there's a little picture of the floppy disk that does the save. All right. You were doing exercises 2 and 3. I'm gonna do that now. Exercise 2 is change the color of the block in the 3rd row and 4th column. And I'm gonna switch to the format that Luke used, where instead of pulling out a block, variable, I'm going to assign directly to the grid. So third row, so that's index 2 for the row, fourth column, index 3. And then I'm going to pick the color. And then if I want to see that, so I forgot to put in the grid below that, so I didn't print it. So if I want to see it, I can do it this way. So 1, 2, 3, 1, 2, 3, 4. That was the right spot. And then for exercise 3, changing the block in the lower right corner. So that's down here. Grid 4, 4. Change that one. Here I want to call out a trick for working with the end of a sequence in Python. You can index from the back without knowing how big something is for a lot of containers in Python, especially lists. And you can do that with negative numbers. So -1 is the last index -1 is the last value in a sequence. Index -2 is the second to last, -3 is the third to last, and so on. So if I do -1, -1, no. Change that same one again. So for this grid, 4, 4, and -1, -1 correspond to the same thing. So now you can do exercise 4. Use negative indexing to change the color of the block in the second row and first column. Paul, each cell is an instance of a block object. So this is a little misleading, what I'm doing here. I wrote some functionality into this so that when I do assignment to the grid, instead of replacing that value of the grid with this, it's actually copying the color of this to the block of that thing. Another way to do this would be that's a little bit more, maybe the way I should be doing this, that's a little bit more descriptive, is to do, in here I'm gonna do the answer to exercise 4. So second row would be -1, -2, -3, -4. And first column is here, so all the way back to -5. I can specifically reference the RGB value of that and change its color. Yeah. This is a little bit more clear way of writing this, where I'm specifically saying, get this instance of the grid, or this block out of the grid, and assign these colors to its RGB attribute. But these are functionally the same, not because of something special to Python, but because of how I implemented the block grid class. And kind of the individual, behavior of doing something like this will depend on how the library you're working with was written. Carmen asked, what is the difference between creating a variable and and doing assignment like this or like this. So when we first did this up here, we actually created a specific reference to an individual block in the grid and then modified it, versus these examples where we're kind of doing it all in one. We're referencing the position, the block in the grid on the left side of the equal sign, and the modification on the right side. And the main, they do the same thing. But the big difference is that here we are left with a grid that we can, or we're left with a reference to the block that we could use further to do something with. Whereas for these examples, we're making the modification without ever assigning the block to a variable. So we couldn't do, if we wanted to do another thing to the block, we would again need to reference it this way. And whether you pick to do one of those or the other is kind of going to depend on what you're trying to do, whether it's more convenient to have a reference to that block for a little while, or whether you only need to reference it once and doing it this way is enough. Exactly, Kyra. It's just a decision of whether you want to retain a reference to the block for another line of code, or whether you want to only need to reference it once like this, and it's easier to do it this way. Okay, what's next? All right, so now we're going to move on from doing these one at a time to working on the entire grid. And so now we're going to get into a little bit more power of things, where we want to loop over the contents of this container and work with every piece of it. So we're not having to kind of manually do things one at a time. So we're going to introduce Python's for loop syntax. So this is the start of a for loop. Starts with this for keyword. These spaces are important because they separate the different words. And you can kind of just read it and guess what this is going to do. But the container is here at the end, the thing you want to iterate over. And then with this particular syntax in Python, which is by far the most common loop syntax, what's going to happen is that Python is going to repeatedly call the code, run the code that we write below this, where the first time it runs it, the value of block is going to be the first thing in grid. And the second time it runs it, the value of block is going to be the second thing in grid, and so on. We'll see that illustrated. And then notice the colon here at the end. That's important. That separates the definition of the for loop from the code that gets run in each iteration of the loop. When I press enter here, you'll notice that the cursor is 4 spaces over from the left. Jupyter has done this automatically because it knows that in Python, you're required to indent the block of code that runs as part of the loop. If we were to take out these, if I was to take out these spaces and write it over here, write code over here, it would be an error. So we want to make sure that those spaces are there. And luckily, Jupyter knows this and will automatically put them there. We'll come back to these questions. You'll see how the order of this in a second. What's going on here? Because yeah, there's a question of like, what do you get when you write syntax like this, especially with a two-dimensional structure? With a one-dimensional structure, it's very easy to imagine that it's going to give you each item individually. With a two-dimensional structure, it's an open question. I've implemented it in a specific way that you'll see. We can do the same operations that we did before. So here I can assign a new color to that block. When I'm done with a for loop and I want to kind of exit the stuff that's going to happen in every loop, I remove the indentation. And then I can keep writing code. Here I want to display the grid, so I'm going to type grid here at the end. So what's going to happen here is that Python is going to execute this line 25 times, once for each grid, each block in the grid. And then it's going to notice that it gets to the end of here and move back to, and then continue execution with this line only after it's run through here. Right, so my expectation is that this is going to reset the entire color of the grid to this blue-violet color. And indeed it did. But yeah, we have that question of how exactly is this iteration happening? And even before this, like if you were to do this, does it return? I could have implemented this so instead of returning an individual block, it returned a row of the structure or something. But to actually see what's happening in every loop here, we can use a feature of Ipython Blocks, this Animate method, and I'm going to do the same thing. But now when I run it, it actually shows this in action. Oh, and in this case, I didn't actually need to echo the grid because it left it, the animation left it up. So if you missed that, I'll run it again. I'm going to take out that last grid. So it's doing every grid in the first row, and then, or every block in the first row, then the blocks in the second row, then the blocks in the third row, and so on. Yeah, Sean, you don't have to, the way you indicate the end of the loop block is by the indentation going back over to the left. Paul's asking what kind of container is grid. You could go read the code, but I'll give you the shortcut. It's implemented as a list of lists. Lists are a built-in Python data type that are one-dimensional. You don't have the option of having more dimensions. So it's a list. Under the hood, there's a list. The whole thing is a list where each element is a list containing each row, and then each element of that is a block. The syntax of working with these block grids is intentionally very similar to NumPy. But under the hood, NumPy is different. NumPy is not a list of lists underneath. Carmen asked, why do we need to write .rgb after every block? here when we didn't have to do that here. And the reason is because now we're not making the assignment to the grid. We're working with an individual block here. So if we were to take this out, what we would be doing is making the block variable a reference to this color, not changing the value of the block, so the value of the color of the block. So since we want to change the color of the block, we need to actually specify the attribute of the block that we want to change. Okay, you are ready to do an exercise, exercise 5, which I'm going to just break for a second since you've probably already done this. So and that's just to do this and reset your grid to one color using a loop. So we'll just break for like 30 seconds for that and let everybody get caught up. Thanks everybody for the questions that you're throwing out. That's great. Love having questions anytime, any question. And if I have not answered your question, feel free to repost it. All right. Hopefully that worked for everybody. We're going to get real fancy now and throw in some conditional logic. Oh, we've got questions, so we'll hold off on that. Okay. Aaron is asking about the negative indexing. Yeah, it's kind of funny, right? So if this is 0, 0, if we were thinking of this as like a Cartesian grid, -1, -1 would be up here, right? And negative numbers would like go off this direction. So this is where the conception of this as like a Cartesian grid breaks down. When you have a container, a container is not a Cartesian grid. There's no, there's no logical like version of, in a container there's nothing before the first element. So containers don't kind of naturally have a negative index space like actual space does, or like a Cartesian grid does. So we have the opportunity to use negative numbers in a different way by assigning them meaning referencing from the back of the container, to say like negative numbers are like turning around and looking at the container from the back end, and -1 is the back, the very last element, -2 is the second to last, and so on. So with positive numbers, you can think of a grid in a very similar way you do as a Cartesian grid for positive numbers, but for negative numbers that doesn't work. It's not working like that. Hopefully that answered your question. See, Neiling asked, what key combination did you use to see the colors changing one by one? That was coming from this grid.animate. So when you use this grid.animate syntax, the iteration will happen along with a display of the grid at every iteration of the loop so that you can see it happening as it goes. Paul asked if it's a list of lists, why does the for loop referencing the component blocks instead of the rows? And again, that's because of the way I wrote the code underneath. If you had a list, if you actually iterated over a list of lists using the syntax, what would end up in this loop variable is the lists. I can show that real quick. These square brackets is a list literal to construct a list. So when I do that, the individual value is a list. However, I have written the code in grid that controls the iteration such that it yields the individual blocks one at a time, row by row, instead of the blocks. That's a design choice I made. Yeah. So Carmen asked why the first object is 0, 0 instead of 1, 1 if the last object is -1. You know, I don't know if I have a good answer for that. Python, the designer of the original kind of designer of Python decided to go with zero-based indexing, which I think is the right choice, but it is just a design choice. There's no rule that you have to do that. But I think it works well in a lot of cases to assume it starts with 0. It helps a lot when you do something called slicing, which we'll see in a little bit. But then when you get to the indexing from the back with the negative, -1 is where you start, and so that side works that way. You might be able to find discussion out there so the Python was originally written by a person named Guido van Rossum, and you might be able to find some information out there about why he chose zero-based indexing for Python. It's a design choice. Yeah, so let me give a couple more examples of the negative indexing. I'll just do it here, I think, because with the tooltip. So this is 2, 3, third row, fourth column. Negative, it would be -1, -2, -3 for the row, and -1, -2 for the column. So this one here would be -3, -2 if you were indexing from the back. So the way to do it is to kind of go to the back and do it backwards, but instead of starting at 0, you start at -1. So let's say this one here would be -1, -2 for the row, -1, -2, -3, -4, -5 for the column. Does that make sense, Aaron? You'll play with it till you get it. Okay. We've had about an hour pass. I'm wondering if we should break, and we only have about no, we have 2 hours left. But let's get through ifs, and then we'll take a break. So let's get fancy with if statements. If statements are a way of what you call conditionals in programming, where you want to say, if some condition is true, do something. But if that condition is not true, don't do it. And so I'm going to show an example of changing, using the same loop syntax. But when we did this before, it changed every block in the grid. This time I only want to change the second row. So the syntax looks kind of similar to for. It starts with the keyword that says, this is the kind of expression statement I'm making. It ends with a colon. When I press return, we got indentation again. And then in between here, we have the expression that we're testing to say, is this true or not? When it's true, the code below here will get executed, or the code kind of indented here will get executed. When it's not true, it won't. It'll get skipped. So let's have it do something. So nothing happens for a minute. Oh, wait, so I changed the third row because dot row. So this dot row attribute says what row of the grid it's in. I tested whether it was equal to 2, so that's the third row, zero-based indexing again. And when it's true, it got changed to black, and we saw that go by. Note the difference between these equal signs. One equal sign is variable assignment, meaning take whatever's on the right and assign it to whatever's on the left. Comparing two things for equality, it uses two equal signs. If you put one equal sign here, you'll get an error. If you put two equal signs here, you would actually not get an error, confusingly. It would just test whether these two things were equal, and that would return a value. So it's saying if the block, whatever value is at block.row is equal to 2, do this. If it's not, it just skips this. There are other comparisons. Yes, equal is a Boolean comparator, and it returns as an expression, it returns a Boolean value. So I can do, let's see, grid 2, row. This will actually return a value and says, yes, that is true. Some of the other comparators, so we saw equal. So Python equal, there's not equal, there is greater than, less than, greater than equal, less than equal, are the typical comparators for if statements. Aaron asked if Python is really that slow. Python is not really that slow. What we saw here when we did this is that we're still looping over the entire grid. So it had to get through this row, and then this row, and then this, and this, and this. And I have programmed this to not run very fast so that we can actually see it working. If I didn't slow it down, it would happen instantly. And we wouldn't get to see the progress. Okay. Yeah, we'll see. Roberto asked about having more than one expression in an if. We'll see that, and yeah, you can put them together with and or. It's not the symbols. It's literally the words and or. But we'll get to that. Okay. Just like block.row, there's a block.col. It's a COL that contains the column index of the block. And you will need that for exercise 6, which I will give you a couple of minutes to do. So use a for loop and an if statement to change the color of every block in the 4th column of your grid. Okay. So we're trying to turn the fourth column. Exercise 6, fourth column. Yeah. So fourth column has index 3. And then change the color of that. That. So we see fourth column, every time it hits that, changes the color. Cool. And David says, I tried setting the block to grid 2, 3 and run the for loop to change colors, but it still started at 0, 0. I would need to see the syntax of what you're doing to explain that. The actual code. David, if you want to paste in the code here, I can try to explain it. Let's see. So here we've done one if expression. Sometimes that's all you need. Other times you want to set up a more complicated thing. We'll look at both, like having more complicated truth evaluations, like if this thing is true and this thing is true, or this other thing, or you might have multiple branches where you say, like, if this thing is true, do this. If this other thing is true, do this other thing. If or in all the remaining cases, do this other thing. So let's look at how to do that. I'm going to demo changing first row black, the third row white, and every other row blue. So first row black, that's index 0. Now to add on another condition to test here, we use the elif keyword and do another test. So third row, index 2, block.rgb equals colors.white. And for a catch-all, for everything that doesn't match the prior conditions, we use the keyword else. Right, so these are all exclusive of each other. Only one of these branches will run. So if this first one matches, it'll run this and then go back up to the top of the loop and so on. Only one of these. So even if a block were to match this condition and this condition, it can't in this case, but imagine different conditions. Then it would still only run the first one it matched, and the rest would be skipped. So let's go ahead and run that. First row, that one turns white, the rest should turn blue. Yeah. Yeah, that's how you do it. Time for exercise 7. Change. So use the same code from exercise 6 and add on making the second column red and third column green and every other block gold. Or you can, it's very similar to exercise 6, so you can kind of copy and paste that and start from there. But don't forget to change the test since you're changing the second and third columns. So David, the syntax of the syntax of this loop here, where we're saying for block and grid, is always going to loop over every block in the grid. We'll see some options next for not doing that and targeting specific parts of the grid that you're interested in. But this particular syntax that we're using so far is always going to yield every block in the grid. Is that answering your question? Cool. Actually, stop this. So we're doing exercise 7. Second column red, third column green. So second column is at index 1, red. Third column is index 2. Else. That. So you've got that. And now to the next bit of fanciness about, yeah, you get used to that with the colon. I don't spend enough time in Jupyter these days. I'm always forgetting to whether I should press enter or shift enter and mixing the two up. And I'm actually conditioned by Slack to press shift enter to enter a new line. So I'm not used to pressing shift regular enter in here to get into a new line. Okay, so we want to get a little fancier with our if statements in the other direction, where we want to create more complicated expressions to say, if this thing is true and this other thing is true, or conversely to use an or, if this thing is true or this other thing is true. So we're going to do that. Next, same setup for now. So we're looping over every block in the grid and doing conditional tests. So these things here, right? Let's say I had multiple columns. I want to change the same color. So let's say the third and fifth columns I want to change to the same color. So third and fifth, that's index 2 and 4. In this case, it's an or, because if they can't both be true at the same time, so and doesn't make sense. You use or. In Python, these Boolean combinations are the words and or. Anaconda J. Okay. It's not very different from gold, but hopefully you caught that. So let's do exercise 8. And change the colors of the blocks in the first and fifth rows to black. First and fifth rows. Yeah, Carmen, we'll take a break in just a few minutes. Almost done with this section. Do 1, 2, 0. So first and fifth, I think. So. Row, wait while we get through the middle, last row turns black. And then finally for exercise 9, you're going to use and. For this one, it's helpful to know because you need to test whether a block is in the fourth column and black. So you'll need to combine that. To test whether, there's a couple ways to test whether it's black. You can use the .rgb attribute and test whether that's equal to black, either using, I'll show you a couple ways you could do, but the simpler way to do it is to use the .red, .green, and .blue attributes. Color for the block. And for black, those will all be 0. And this is the last thing we're going to do before we break. So we want to change all of the black blocks in the fourth column blue. So that would be that one and that one. But I do it this way. Index 3 for the fourth column. All right, but now we need to add on some other stuff. And so you're not limited to only 2 of these. You can have as many conditions as you like. You can group them with parentheses to create like a hierarchy to say like test this condition first, this pairing first, and then test this other pairing, and so on. Yeah. And then I want to change, when that's true, I want to change it to no, that worked. I mentioned that you could compare to the RGB attribute too. That's another option too. It's just requires a little bit more. It's not quite as conceptually simple as testing against the integer numbers, but this would work as well. but let's make sure it works. So now that they're blue, we'll change them to red. Yeah, okay, that worked too. Okay, that's it for, we'll take another break, a little bit longer this time for 10 minutes until 40 after, and then keep going. And again, I'll be here for any questions while we're on break. We'll resume at 11:40 in the conference time, 40 past the hour. Block.red equals 0. So a common way of representing colors in for computers to understand is breaking the colors into red, green, and blue components, and saying this much red, this much green, this much blue. There's a range. The range is 0 to 255. So each of those components is 0 for a color that's black. They're each red for a color that's green. So one way to test whether a block is black is to test individually whether each of those components is 0. So comparing when we say block.red equals 0, we're testing whether the red component of the color is 0. That's true for black. It's also true for like pure green or pure blue, and so on. Any color that doesn't have a red mixed into it. Aaron's asked, as we move on, we're going to have a different way of animating it that I'll demonstrate, since we're not going to be looping over the grid in the next section. I'll show you how to do that. But yeah, the animation and the pausing is implemented in that animate function. Come back in 8 minutes. Hopefully that's long enough. Paul asked if it's possible to slow down the animation. I think it is. So you see here in grid, I pulled up the documentation for grid.animate. You can pass in a number here. So if you pass in a bigger number, it'll go slower. And that's in seconds. So if you were to pass in a 1 here, it would stop for 1 whole second between steps. Okay, I'm going to step away for a minute. I'll be right back. I'm here if anybody has questions in the couple minutes before we resume. Yeah, I can try to slow down a little bit, Kyra. Yeah, happy to take questions. Makes it better for y'all. Interesting. Try that out. It is supposed to be in seconds, yeah. Okay, so it's working for me. Wonder why it's not working for you. Is that all by itself in a cell, like I did it? Is there anything else in there? Yeah, that's possible. To stop a cell from running, you go to kernel and interrupt. Or probably there's a big square button. Yeah. Yeah, I bet that works. Luke, you'll see this in a second. There's a grid.flash thing that we can use in the next section for animation. Okay. I get started again. Just wanted to encourage everyone. You're not on screen, so you have the luxury of eating as we do. So make sure you're staying hydrated and fueled as we go. Learning is hard work. I learned in the last year that like chess players use a ridiculous amount of calories during competition just sitting there thinking. So it can be a real energy drain doing this stuff. So don't forget to take care of your brain. So this next section here, as we've been working so far, these loops are visiting every element of a grid, even when we were only interested in a couple of the elements, maybe one row or one column. And sometimes it's appropriate to loop over every element, sometimes it's not. We want to be more targeted for the cases when we don't need to visit every element, so we're not wasting cycles. And we'll see a couple ways of doing that. So one common way of doing looping is to loop over a set of index values so that you are specifying ahead of time which set of index values you're interested in, and then looping over only those. So here, instead of looping over the blocks in the grid, we're going to generate sequences of numbers, loop over those, and modify the grid using those index values. So as the tool we're going to use for generating those values is a function called range. So let's take a look at that. So it's got a couple of examples here. You can call it with one argument, which is the stopping point, or you can call it with more arguments in order to specify a start, stop, and step size. The default step size is 1, and the default start is 0. I'm going to close this, and to give a couple of examples, if you use range by itself, it just returns a range object. It's not until we iterate over it that we actually get to see the individual values it generates. One way to do that is to convert it to a list. So we can see that this generated the values 0, 1, 2, 3, 4, which are the values you would need to index into a sequence of length 5. So this stopping point is not included in the range that's returned. Because usually, a lot of times you do this where you say, I want to loop over a range of length 5 so I can index into something that has 5 elements with indexes 0 to 4. So let's say I want to change every block in the second row. And here I'm going to, so to change every block in the second row, I need to loop over the columns. So this time I'm going to make my loop variable, which I'll write a column in range. And now I need to specify the range. I could write 5 here because I know my grid is 5 by 5. Or I can specify the width of the grid, because that's how many columns are in the grid. And change the now let's do grid. The row is not going to change, so I can hard code that to 1 for the second row. Specify the column and change the color. Now, since we're not looping over the grid, we don't have access to the animate function, but there's another one called grid.flash that will display the grid for a second and then pull it off again. Because it pulls it off again, if we want the grid to show up at the end, we need to echo that again. So let's see if this works. All right, so that did it. So that one much faster than we've seen this before, because it only, even though it was pausing for the same amount of time in the between the loop elements while Flash ran, it only did 5 loops instead of 25 loops. So you've got everything you need to do exercise 10. So now we're going to make a new, bigger grid, 20 by 20, and change the color of every block in the 3rd, 10th, and 18th rows. And I'm going to give you 3 or 4 minutes to do that. Okay. I have my solution up here. Pretty similar to the demo I did before, but doing the assignment 3 times since we're changing 3 rows. Carmen asked, can you explain the intuition of why we have to iterate through columns when we want to change on rows? Yeah, so we're thinking there about what is staying constant and what is changing based on what you want to do. So in order to change everything in rows, the row values are staying constant, or maybe they're like in the case where I want to change just one row, the row value is staying constant. The row and then the column is changing. So that's why we need to iterate over the width and change the column index, because it's the column that's differing each loop through. Yeah, so that's the thought process. It's thinking through like, okay, what is the differing value between these different things that I want to change? I hope that makes sense, Carmen. I know that trips me up every time trying to think about like, oh, I'm changing rows. That means I iterate over columns. But you have to stop and think about what's changing. It trips me too. That's why it's nice that we get the visual output here, because you get a very, if you mix it up, you get a very quick reminder that you need to rethink it. Aaron asked about where I put grid.flash, and it doesn't matter really. The only difference is what is the state of the grid you want to see. You could put it in between each of these if you wanted to see the individual statements at work. If you put it here at the beginning, you'll see the initial like blank slate state of the grid. If you put it here at the end of the loop, you'll see it after it's done its initial feed changes. It doesn't matter. Emily, Flash, since we can't use grid.animate here since we're not looping over the whole grid, so Flash is another solution to that, where it like displays the grid for a second and then like takes it back off like an animation frame. If it didn't take it back off, they would just like a whole bunch of them would show up. If you did grid.show, for example, it wouldn't get removed. It would just stay there, and then you get a whole bunch of them for each loop. Let's see if this works. So there goes. So as you can see, it's doing it all 3 at a time. Paul, we'll get to, yes, we'll get to that next. So instead of having to specify, since I'm changing each of these to the same color, another solution here, instead of listing these all out, would be to then loop over the rows. For a case like this, where the rows are not next to each other, I might just list it out in a list. An equivalent. It doesn't matter which one of these is the inner loop and the outer loop. The end result would be the same. But sometimes we want to, let's say we're targeting like a subset of this grid, like rows 6 to let me actually write this down. 4 row in grid. Well, let's start with row 6, not grid. Range. Start with row 6 and go up to 13. And then for column range, and we'll do like 11 to 16. State of the grid. Change a color. See if this works. Okay, so here it's going over this little section of the grid. Sorry, the color doesn't contrast very well. Roberto asked if we wanted to iterate on only even rows. For something like that, we can use range. And specify a step size. Here, so this third argument is how much it adds to the initial value each step through. So it'll be 0 the first time, then 2, then 4, then 6, and so on. So as long as the rows you want to visit are evenly spaced, you can use this concept of a step size. Can you define a function for it? You can. I'm not going to go into it here, but Python has a really cool concept called the generator function, where you could where you can write a stateful function that is meant to be looped over that yields individually the values that you want. Yeah, let me scroll up here. So you can do exercise 11 now, where you want to change the color of the bottom left quadrant of the 20 by 20 grid. So that's going to be the last 10 rows and the first 10 columns over here. All right. And unfortunately, with a grid this size, I have to scroll my code off the top there. And I will start putting in my solution to this. So last 10 rows. We start at 10, and then for an ending point, we can do height. Say we want to end at the end of the grid. And for a column in range, we want the first 10 columns. So we'll start with 0 and go up to 10. Match the grid. And then change the color. And let's see how that goes. All right. That looks like it's going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. I didn't. This 0 here I could have omitted since it's the default. This could have been only range 10. And I think I could also here, instead of specifying the height, if I know I want it to go through the, oh no, I do have to specify frequency. So I have to specify where to stop. But you don't have to specify where to start if you're starting at 0. We use grid.height here because we need to tell it when to end to get like what is the ending point for this loop. For us, the ending point is when we get out to the end of the grid. So in this case, this will be 20. Remember from my demo earlier, range doesn't include the stop value, so this will generate the values 10 through 19. But the grid.height is here because we need to tell it where to stop. We're generating row values, so we use height because height tells you the number of rows in the grid this direction. And we want to stop at the last row, which will be have an index 1 less than grid.height. If you have a star here, that means there's still a cell executing somewhere, either this cell itself or one above it. You can interrupt. So you might have accidentally written an infinite loop somewhere. Let me turn the toolbar back on. You can tell Jupyter to stop running by pressing this button, and it'll interrupt whatever it's doing. But it may also just be still cycling through your things. So Aaron asked, why does range 0, 10 stop at 9 instead of at 10? Range doesn't include the last value, and that's to match Python's zero-based indexing. So if I do this again, let's do. If I have something that is 20 elements wide, I can get a sequence of all of the values used to index into that very quickly by passing the size of that thing to range. Yeah, and it doesn't make sense for this to include 20 because there is no index 20 in something 20 elements long because of the zero-based indexing. Yeah, so the endpoint is always one less than the stopping point you specify. And it's for this reason. Let's see, Marissa got an error. So it looks like you've got a nested call to range in there. So it should be for row in range 10, comma, grid.height, where you've got the extra call to range around grid.height. Let's see how I've got it here, Marissa, where it's range 10 space grid.height. You have an extra call to range inside of there. Aaron, yeah, like it's in computer science and mathematics, you'll hear like a closed, or what are the terms they use? For like the inclusive or not inclusive elements of a range. So like a range is inclusive on the low end and exclusive on the high end. I'm doing my hands like this because they designate that with like a square bracket for the inclusive and a parenthesis for the exclusive side of it. Okay, so that's range. This kind of thing comes up so often that where you're working on a segment of a larger container, especially when you're working with numbers, there's a shortcut for it in Python, and especially this comes up in NumPy and Pandas, that there's an abstraction that moves the loop out of your code and into library code. So we can express the stuff we've been doing kind of in one statement where we don't have to write the loop. A loop is happening somewhere, but we can express it in an abstracted way. And it's called slicing in Python. So I'm going to demonstrate doing some slices. Start with the grid, and I'm going to pick which range I want to do. Okay. So this is the equivalent of looping over a range 2 to 4, and for the rows, and 1 to 3 for the columns. But just like range, the slice syntax does not include the stopping point. So this is rows 2 and 3, columns 1 and 2. So let's see what that does. So that did rows 2 and indexes 2 and 3, and column indexes 1 and 2. So we sliced out this little two-dimensional square there. Marissa got a little bit ahead and started playing with the open-ended ranges. So sometimes when or sorry, Marlene, it's fine. Sometimes you want to or can omit like the start or the end because you want to go from the beginning or all the way to the end without having to specify them. And it's really nice for doing the end bit because you don't have to think about what the size is. You can just say from this point through the rest of it. So the syntax for that, when you want to omit the beginning, which defaults to 0, or the end, which goes through the end of the sequence, is to just leave it blank. So if we do grid, let's say the first 5 rows and everything from column, let's see, 15 on, so that did over here. So first 5 rows, all the columns from 15 on. Yeah, Aaron's pointing out the similarities between ranges in Excel and the slice syntax in Python. And it sounds like they're pretty similar. You can even entirely omit the start and the end, which comes in handy when you don't have a limit on one of the dimensions. So if we want to change everything, if we want to change every row in the, I don't know, 9th and 10th columns, we say colon, which means all rows, and then the 9th and 10th columns. And you can even specify the step size. So let's do rows 10 to 17 in steps of 2, every column. So that did every other row in that range. So that's slicing. And you can now do exercise 12. So exercise 12, you're repeating exercises 10 and 11, but using slicing instead of loops. So slicing is a pretty powerful concept, and I spent quite a while showing you loops, but a lot of applications in numerical computing, you don't have to write explicit loops, at least at this level. You can do things like slicing instead. So to repeat exercise 10, we could do an outer loop over the row indexes and change them to, and then do a loop where we can list them all individually. The bottom left, so that's last 10 rows, first 10 columns. And the zero-based indexing comes together like really nice in this kind of expression. When you want to express things like first 10, last 10, things like that, you don't have to think about whether, do I subtract a number or do I add a number there. So looks like it worked. Okay, we're about to change topics a little bit. So any questions about slicing, for loops, if statements before we do that? Paul has a question. Kaylin Marie too. All right, okay. So Kaylin, paste in, Kaylin Marie, paste in the whole text of that error. That'll help me. Interesting. Again, maybe I think I could use a little more info. Where it might be on that first line where you're doing the block grid. I'm not sure why it's saying it's a tuple, but block grid has capitalization, the B and the G. Python is sensitive to case. And to Paul's question about the slicing, you need to think about the stopping point. So when you do 10, 17, 2, let's look at that. So I'm actually going to demonstrate this. You can construct slices using a slice function as well, though this is pretty rare and mostly you use the colon syntax. But if you want to construct a slice and pass it around, you can. Actually, I'm going to use range since it has the same semantics and we can list it out. So if we do 10, 17, 2, let's see what we get. 10, 12, 14, 16. So I would expect that, yeah, so that does 4 because you get to 16, which is less than the stopping point. If you put 16 as the stopping point, you would only get 10, 12, and 14, I think. Yeah. And then if you look at 2, your other example is the equivalent of this. So you get 2, because it always includes this. Then it adds 17. So the next value is 19, which is less than 10, or more than, which is more than 10. If it was equal to 10, it would also stop. So it's higher than the stopping point, so it doesn't include it. Yeah, so that third value, yeah, so in a slice, it's start, stop, step with the exact same semantics as range. So if you ever want to test out how a slice works, you can do the same thing with range. So if you want rows 2, 10, and 17, those are not evenly spaced. So you cannot express that with a slice or a range. You have to list them out explicitly or kind of write your own function for generating those values. Lists, range, and slices can only construct evenly spaced intervals. Great question, though. Okay, any more questions about slicing and loops and range? Okay, so we're getting into the last half hour here. And I don't think we'll get through the rest of the exercises, but I do want to show you one more feature of Python. We've been writing all of this code so far, but when you get down to work, you're not going to want to write out your code separately for every instance. What you want to do is construct reusable bits of code that you can call again and again on different inputs. And for that, we write functions. A function is a way of encapsulating a bit of code so that you can run it over and over again by calling it instead of rewriting it. So let me show you a quick demo of a function. So it starts with a keyword, kind of like for. It's called def, D-E-F. I'm going to write a Fahrenheit to Celsius conversion function. And so what I list in this is the name of the function, how I'll reference it to call it. Then some parentheses. Any arguments to the function go in here, separated by commas. If the function doesn't take inputs, you don't put anything here, but you still need the parentheses, so it would look like this. Then your function can be as long as you want, separated by lines. Note the indentation. Again, the indentation is important. This is a simple function, so I'm going to skip straight to sending a value back. So you use the return keyword to say, this is the stuff I'm sending back to wherever this function was called. It's optional. Not all functions have to return something. And then I'm going to do the math. Using some parentheses to group the elements. And execute that. It doesn't print anything, but now I can call it and do some conversions. So as a test, 32 degrees Celsius should be 0 degrees Fahrenheit. Cool. And then I heard it was 114 here in the Central Valley, here in California over the last few days. So let's see how hot that is in Celsius. That does not look fun. Yeah, so that works. So you can see that value is coming back. I could capture that in a new variable. Like 60 degrees here where I am. Right, makes sense. So whatever value comes back from return here is what ends up in this variable when I write out an assignment like this. We could do right is even function and return if the percent sign is the modulus operator in Python. So this will return 0 if there's no remainder to the dividing number by 2. So here I've got 2 return statements. One for the case when it's true, one for the case when it's false. You can have as many return statements as you need in a function. Usually you don't need that many. And you want to avoid having too many because it gets really confusing to track where a function exits. But you can have as many as you need. Kyra asked if you need to put else there. I could, but this is equivalent since there's only the one if check. If this is true, it'll end up here. Otherwise, it'll end up here. It doesn't matter whether I put the else there or not. It's going to be the same code. But good question. So let's see if that's right. That's true and false. I hadn't explained this. These are the first time we're seeing these really. These are literal Boolean values in Python, true and false. There's another value that comes up sometimes called none that can be useful in some contexts, but you'll see it if a function doesn't have an explicit return, it returns none implicitly. And there's one place you'll see that come up. Sean asked, does it recognize all functions you've created above? Yeah. So here in the notebook has like a global namespace for things you've defined in a cell, as long as it's not nested in something inside of something else. So if you define a variable inside a function, it's local to that function. But stuff you've defined at the top level is accessible. So for example, I could write a function and then inside that function call the Fahrenheit to Celsius converter function, or the is even function. Okay, any questions about functions? Okay. I expect this will be the last thing we get to. is exercise 13. And the goal is to write a function that takes a grid as input and returns a new grid. That is, it does not modify the grid you put in. It makes an entirely new grid with the same size. And it returns that new grid with the colors as the inverse of the colors in the original grid. So if you've ever seen like a negative image, it's kind of like that. So we're going to take a grid and like return the negative inverted colors of that grid. So before you write the function, it's useful to think about like how you invert a color. And maybe even let's write a function for that. Anybody have thoughts about what the inverse of a color, how you calculate the inverse of a color? Jeremy suggests 255 minus the current color, and that's it. So if I wanted to take like an RGB triple and return the inverse of it, I can do that. Actually, let me make this a little bit more complicated. Or less, use some variables. So if you were to pass in one of the things from for example, from invert color, let's do a simple one. So blue is 0 red, 0 green, 255 blue. So this should return 255 red, 255 green, no blue. And then if we pass in one of the elements of my grid, RGB, this should work as well. So whatever color that was, this is the inverse. And yeah, so that's how you invert a color. And you can use that for this exercise. So again, the idea is you write a function that you want it to be reusable in general for any grid that gets passed in. So it'll take that grid and not modify it, but return back to the user a new grid that is the inverted color of the input grid. So go for it. And I'm going to kind of slowly fill in my solution here, like one line every 30 to 60 seconds. So if anybody's stuck, hopefully I'll catch up to you, and you can kind of verify as you go. So since we can't modify the input grid, first step, create a new grid we can work with. right, how are folks doing? All right. So I wrote a solution. So it starts off by creating a new grid. One way to do that is to use the information from the input grid, call the block grid class constructor using the attributes of the input grid, create a new one, or add. Remember that I have made a copy method on these grid classes, so there's also a way to get a copy. And then to do the inversion, using the stuff we've seen already, you loop over all of the rows, all of the columns, by using the attributes of either the input grid or the new grid, it wouldn't matter, but by using these height and width attributes, we make this function able to work on grids of any size. You could independently modify the red, green, and blue values on the new grid to invert them relative to the input grid. Or since we already wrote a function that does that, we can call that function and say new grid row column.rgb equals invert color of the input grid.rgb. And then finally, we can't forget to return the new grid, but we want to make sure we do that indenting back out to this level so that it's outside these loops, so that we loop over the entire grid before doing the return. So, moment of truth. Yeah, let's see if it works. Oh, no, it's not going to display that, huh? Maybe if we do this. So my input and my output. It's kind of hard to tell, but this is the input, this is the output. So the black background became white, these lighter rows became dark, dark green inverts to light pink, so on. So that seems to have kind of worked. So again, a function. Just for kicks, I kind of want to show another way of doing this. That I don't think I have time to explain it in depth, but it's a nice feature of Python. For doing the loop. When you want to loop over two or more things of the same size that have the same like iteration semantics, there's a function called zip that can help you with that. So if I do new block, zip, new grid, input grid, and then return new grid. See if this works. did the same thing. Cool. So this zip utility iterates over this one and this one as if you had written like 2 levels of looping, and returns them as a pair. Yeah, Sophia, I will save this and push it up to the repo when we're done here. Okay. Any questions in the last few minutes about literally anything? Anything we've covered, anything we didn't cover? Quick demo of zip. So I'm going to kind of do a demo. So I'm going to list zip. I'm going to zip together 2 ranges. These are the same size. I'm going to kind of indent these so it's a little easier to see the arguments. Zip is like range. It doesn't return a container. It returns like a generator, which is something you can iterate over, but it doesn't generate all of its values at once. So that's why I wrap it in list to make sure it actually generates all of the values into a list we can see. And then I'm zipping together a range from 0 to 5 and another one from 5 to 10. And you can see what this generated was pairs of the first thing from this range and the first thing from this range, and then the second thing from the first range and the second thing from this second range, and so on. And so when it's possible to loop over this, unpacking these pairs into loop variables. By listing out, because zip with 2 arguments is going to return these pairs, by listing a pair of names here, I can access both of them in the loop. So there's a bit of unpacking going on here. And unfortunately, I'm not going to be able to show this and my code on the screen at the same time. Is this the part you wanted to see, Aaron? Lena, the %sign operator is what's called the modulus, and what it gives you is the remainder of dividing the left side by the right side. So if you were to divide 10 by 3, the remainder of that is 1, because 3 divides evenly into 9, and you're left with 1. So 10 mod 3 equals 1. So for our applications with the isEven function, if a number divides evenly into another, the modulus of those will be 0. So to test for an even number, you can use the modulus to say, like, does 2 go evenly into this number with no remainder? Paul asks if there's a construct that will let you loop or slice over a list of items. Aaron, is it oh, oops. What did I just do? Okay. Aaron, is it okay if I scroll away from this? So if you have a list of a plain old list of items, remember so these square brackets with items separated by commas is the literal way to make a list. If I want to, so lists, you can slice. This is a pretty short list, but if we do 1 to the end, it returns a new list with index 1 through the end. I can loop over it with the same semantics as the grid, where it's going to give me the first item and the second and third. Does that answer your question, Paul? Okay, so I would expect your code to do what I think you're trying to do, where it changes every column of the 3rd, 10th, and 18th rows to violet. But you're not seeing that? Cool. Yeah. I know you were asking before about how to about like trying to construct something like that. You can't, except kind of manually using your own logic, since it's not evenly spaced. Okay, yeah, I had to get some parentheses straightened out. There you go. All right, anything else? We're at the top of the hour, so we probably need to stop. Like I said, I am going to push this up. You can even watch me do it. Now, if we go back to the repo and open this Playing with Blocks notebook, this may take a minute, but there it is. Oh, yeah. So GitHub doesn't render these correctly. The tables correctly, but if you go to nvviewer.jupyter.org and then paste it in, hopefully this will work. There we go. This NV Viewer is a nice tool from the Jupyter team for if you have a notebook online somewhere that you want to share with somebody else and you want it to be like fully rendered, because the actual file format of the notebooks is like a format called JSON, not something a human can read. So when you want to share it with somebody else, you can send them the file and they can open it if they can run Jupyter. But if you have it online somewhere in public where NV Viewer can fetch it, you can use this tool to share it. Yeah, the brackets versus parentheses, you get used to it. Think about whether you're calling something, a function, a class, or a method, or whether you're indexing into a container. The square brackets are only used with to pull something out of a container. I shouldn't say only, but for the most part, used to pull something out of a container. All right, well, we should probably stop since we're at the hour here. The Slack will be up for a long time, so feel free to use that to talk to us for the rest of the conference. Feel free to send me direct messages on there. Again, I'm Matt Davis, and happy to take questions for the rest of the conference here. You can also get in touch with me separately. Here's my email address. I'm Jiffy Club across the internet because Matt Davis is taken. So Twitter, Instagram, my email, etc. Feel free to get in touch anywhere, anytime. And thank you all very much for coming. Hope you have a really wonderful conference.
Thanks again, Matt. Appreciate everybody attending, and we'll end the session so that everybody can go grab some lunch and head off to their next tutorials starting in about an hour.
Thank you, Eric.